Good evening. Welcome back to AP Stats Notes Online. I want to wrap up Section 8.3 tonight, and so we can start working towards a test. The first thing that we want to talk about here is we've gone through the one sample T intervals and went through the conditions, and again, everything looks a whole lot like it did when we were doing one sample Z intervals to estimate a population proportion. And now we're trying to estimate the population mean. Of course, the difference here, another difference here is that where we get our critical value from has to come from that T distribution. And again, it's because we're using the sample standard deviation in our calculations to standardize that sampling distribution. Right, the approximately normal sampling distribution, when you standardize down to get to your critical values, and we're using the standard deviation of the sample instead of the population, because that standard deviation is calculated a little bit differently, the standard curve takes on a little bit different, a few different characteristics. So we get to this T curve. Okay. The other difference about another difference about a one sample T interval to estimate a population mean is that these procedures are what are called robust. It's a robust inference procedure. What does that mean exactly? Robust means the actual capture rate will be close to the actual capture rate even when the conditions are violated. Okay, now what that means is a 95% confidence interval will have a 95% chance of capturing the population proportion or population mean, as long as all the conditions are perfect and everything is as it should be. If some of the conditions or one of the conditions are violated, then if a procedure is robust, then that capture rate will still be the capture rate. Now, for one sample Z intervals, where we're trying to estimate a population proportion, those procedures are not robust. Especially in terms of the normal condition, if the sampling distribution is not approximately normal, then 95% confidence interval will have a much different capture rate than 95%. Okay, but in our one sample T intervals, that procedure is considered robust. So even if one of the conditions are violated, and we'll again put this in terms of the normal condition, the capture rate will still be pretty close to the actual capture rate, okay? So what do we do? What are we looking at here? So what are some guidelines we can use when checking the normal condition? And again, this is tied to the normal condition. I haven't seen much in the way that lets us know that if we're not sampling randomly, or if we're sampling more than 10%, that our procedures are considered robust, whether we're talking about a Z interval or a T interval. So this is all about the normal condition. Okay? And there are some guidelines as far as this normal condition goes. What we can accept as this condition is violated, and what we cannot, and what we can accept and what we cannot accept. And a lot of this depends on the sample size. Okay? If our sample size is less than 15, if n is less than 15, then we're still going to be able to use our T procedures if the sample data, if the distribution of the sample data appear close to normal. No outliers or any skewness much at all in our distribution. So we're going to have to take a look at the distribution of sample data. Or take a look at what our raw data, our raw sample data looks like, okay? Now, this is sort of a tiered structure. If our sample size is between 15 and 30, then we still cannot accept outliers in our sample data. But if there's a little bit of skewness, we're okay. We're just going to try to avoid using T procedures if there's strong skewness in that sample data. okay? And a lot of this has to do with the fact that particularly when we're talking about sample means, the distribution of sample data tends to look a whole lot like the population. So that's why we're sort of, we're kind of making this tie back to the population distribution. We know if there's strong skewness or if there's skewness in the sample data, then there's probably strong skewness in the population distribution. And that's what this is really all about. Making sure that our population is approximately normal the best way we can. Okay? So if our sample size is between 15 and 30, then we still cannot accept outliers, but a little bit of skewness is okay. Okay? And then of course, if our sample size is bigger than 30, then we can use our T procedures even for skewed distributions. We know that the central limit theorem tells us that after a sample size of 30, the population distribution, the shape of that doesn't even matter anymore. We know that our sampling distribution is approximately normal, and we can still use our T procedures as far as coming up with our critical value. Okay? All right. Next question. How can you lose credit for the normal condition on the AP exam? Right, well, we have a normal check for our Z procedures. That's that n times p hat and n times 1 minus p hat being bigger than 10. Well, here it seems to really depend on what the sample data looks like. That and the sample size. So you can't just say we're going to assume normality. That'll lose you credit on the AP exam, right? If your sample size is less than 30, you're going to have to include a graph of the sample data, okay? Now, if your sample size is less than 30, then it probably wouldn't take you a very long time to come up with a quick dot plot, and that would be my recommendation on how to show this. Now, you can type the values into your calculator and get a histogram or a box plot, or you can even take a look at a normal probability plot to see if the sample data is approximately normal, right? But you're going to have to include the graph. So a quick sketch of the graph. And then the other part is not understanding that the condition is about the population. Again, we want to know if the population is approximately normal from what I was saying before. Okay? And again, if our sample size is 30 or bigger, then it doesn't matter. We know our T procedures are okay because the sampling distribution will be approximately normal. Okay? But if it's less than 30, we have to make sure that the population distribution is approximately normal, because if it is, our sampling distribution will automatically be approximately normal. Okay, so it all does kind of come back to the sampling distribution, but the sampling distribution is based on the population. So we have to talk about the normal condition in terms of the population. Okay. What types of graphs can you use to check the normal condition? And I just mentioned a bunch of them. You can do a histogram, a box plot, a stem plot. A dot plot would be fine. A normal probability plot would be really nice. Normal probability plot's kind of tough to graph on paper. So as nice as it would be to look at that thing, we need to find something that we can graph pretty quickly. And again, dot plots are probably your best bet. Okay? All right. Next question before we get into our last example here is using your calculator. Again, on page 514, it'll walk you through how to use your calculator to do your T interval. Are there any drawbacks to this? Sure. They're the same drawbacks that we had with using the calculator for our Z interval. Right? Again, some formulas appear on the multiple choice questions. They'll take your 5 answer choices and plug numbers into the actual formula for the interval and ask you which one's correct, right? And they'll change some numbers around. So you need to understand the structure of the interval, right? Again, on free response questions, you eliminate the possibility of partial credit if you're just going to use a calculator to show the interval. And because on the AP exam that's true, I'm going to tell you right now that you will lose points for not showing the formulas on your test in here, okay? And then you do not get any credit if you don't state the inference procedure and show the statistics. So, open yourself up to partial credit and all credit. So if you do not state the inference procedure and show the statistics, you're going to be in trouble as well. So let's just make sure we show all the work. That's the bottom line here. Okay? All right. Last example here is part of their final project in AP Stats. Christina and Rachel randomly selected 18 rolls of generic brand toilet paper to measure how well this brand could absorb water. To do this, they poured a quarter cup of water onto a hard surface and counted how many squares it took to completely absorb the water. Here are the results from their 18 rolls. Okay? Construct and interpret a 99% confidence interval from U, which is the mean number of squares of generic toilet paper needed to absorb a quarter cup of water. Right, so what this is telling us is that they took one sample, and it took, they did this one time and it took 29 squares. They did it again, took 29 squares. They did it again, it took 20. So there were 18 rolls, and they were counting the number of squares it took to absorb all the water. Now, first and foremost, we want to still keep thinking about these problems, these statistics problems, in terms of the four-step process. What you're going to notice from your book is that that four-step process logo is going to go away. Okay, the book feels like effectively brainwashed you into doing the four-step process, and hopefully we have. But you want to think about all the work that you need to show in terms of those four steps. So whether you actually write out state, plan, do, conclude, and if you want to, you're welcome to, that's fine. Or if you just want to write things in wherever you find the space in any structure that you want, just do it in terms of those four steps, and that way you'll have all the work that you need to get full credit on each problem. Okay, and so the first one, state, what do we want to do? We want to estimate mu, the mean number of squares of generic toilet paper needed to absorb a quarter cup of water with 99% confidence. And we need to be that specific. Generic toilet paper needed to absorb a quarter cup of water. Okay, and we want to do so, and then obviously our confidence level needs to be there, 99% confidence. Okay, plan, how are we going to do this? Well, we will construct a one-sample t-interval, provided the following conditions are met. So now you've listed your inference procedure. We're doing a one-sample t-interval instead of a one-sample z-interval, and there you've gotten part of the credit that you need. And then we go check our conditions. Random. The student selected the rolls of generic toilet paper at random. Okay, and it says so in the problem, randomly selected. Okay, the next issue. Sample size is smallish. There's 18 rolls. And we don't know that the population is normally distributed. So what we have to do is check to see if our sample data at least does not have any outliers or shows strong skewness. Remember, we're in that mid-range, we're in that mid-tier. So if it shows a bit of skewness, we're okay, but no outliers and no strong skewness, right? So we need to go check that. Now, what you use to graph is completely up to you. I think that again, a dot plot is probably the easiest and the fastest way to do this. And we're only plotting 18 numbers. So we need to go do that. So what I would do is somewhere in your space, go ahead and come up with okay, number of squares. Or the mean number of squares used. Okay, and we're smallest at 20, largest at 29, so we could go 20, 22, 24, 26, 28, and 30, right? We've got 2 at 29, 20, 24, 25, 27, 29 again, 28, 22 21s, a 24, a 25 again, 27, 26, 25, 22, let's see, 24, and 23. So you look at that, and there are no obvious outliers there, and there's not really any skewness in your data. And you want to actually show this. Graph this on your paper. Okay? All right? But once you did, you could talk about the normal condition now, right? And so you have this dot plot in there. What you could say is the dot plot below or the dot plot shown here doesn't show any outliers or strong skewness, so it's reasonable to assume that the population distribution is approximately normal. Make sure that you tie this to the population distribution, okay? Because our sample size is small, we need the population distribution to be approximately normal. All right? Good. That normal condition has been satisfied, and so now we can keep going. 10%, since we are sampling without replacement, it is reasonable to believe that there are more than 180 rolls of generic toilet paper they could have sampled from. That's certainly reasonable, and so we can move on. Okay, and then our due phase, right? The sample mean for this data, so you're going to have to go find the sample mean. They didn't tell us what it was, and so you need to type in the values into your calculator and do your one variable statistics, right? Remember that guy, stat calc one variable stats on whatever list you put the numbers into. It'll give you the mean, and it'll give you the sample standard deviation 2.86. So we have to show that X bar is 24.94, S sub X is 2.86. You need to list the degrees of freedom. Okay, these are all things that you need to have on your paper somewhere. Okay, if it's not in this sentence structure, that's okay, but it's got to be on there somewhere. And then for 99% confidence, you need to list your T-star value at 2.898. Now you can do it separately like this and show all your numbers like this. Right? The degrees of freedom you're going to have to write out somewhere. Or you can use the formula to show all this stuff as well. Right? You can put in 24.94 plus or minus, then 2.898, which is your T-star, 2.86 divided by the square root of 18. And this will show everyone that X bar and S sub X are in here and your T-star is in here, but you still have to list the degrees of freedom out separately. This is all the work that you need to show everything that you see on here. Again, it doesn't have to be in sentence structure, but it needs to be written down somewhere. Okay? At which point, once you have the numbers plugged in, you can grab your calculator and do your t-interval from there and just write out the answer. You don't have to do all the calculations by hand, but it needs to be there. Okay? Again, page 514, I think, is where you're going to find everything. I'll go ahead and show you also if you go to stat tests, okay, it's going to be, I think it's this option 8 t-interval. Let me scroll through and make sure that that's correct. Yeah, I'm almost positive. It's going to be t-interval. Okay, I have the data typed into a list, so I'm going to go ahead and just have it pull from the list. Instead of, I haven't calculated X bar, S sub X in my calculator, but it will do it for me. We're doing a 99% confidence interval, and so I hit enter, it thinks for a second, and then it pops out the mean, it pops out the standard deviation for me, and it pops out the interval, okay? And so it's all right there, 22.99 to 26.89. At which point I'm ready to conclude. We're 99% confident that the interval from 22.99 squares to 26.89 squares captures the true mean, not true value, true mean number of squares of generic toilet paper needed to absorb a quarter cup of water. Okay? So do make sure we're showing all of that work. Think about it in terms of that 4-step process to make sure you get all the work in there. Include a graph if your sample size is less than 30, and you'll receive full credit and be well on your way to doing very well on the test in here and on the AP exam. Okay? That's it, guys. Chapter 8's wrapped up. It's time to start working towards our test and reviewing for that. Homework is in your text. We'll see you guys next class period.